Good morning, students. Today we discuss about context-free grammar, simplification technique, and normal forms of CFG. So myself, Mr. C. Radhakrishnan, Assistant Professor, Computer Science and Engineering, Command College of Engineering and Technology, ToC. Before going to the normal forms, the grammar we required for simplified format, that particular situation, the grammar which is not contained the some epsilon rules, unit productions, and useless symbols. If it is presented, we need to be eliminated. Now, before the normal form discussion, we go with the simplification of the CFG. So, simplification of CFG means what are the points we are having? Totally three different combinations of three different simplification techniques are there. First one, elimination of null production. Second one, elimination of unit production. And third one, elimination of useless symbols. The elimination of null production means, suppose, if null production we defined as epsilon. That case, we need to be eliminate epsilon without changing the meaning, of the grammar, we need to be simple. Whatever the problem is given for simplifying the CFG, first step, write the given grammar. Here consider S is equal to AB. A gives small a, capital A, another alternative also epsilon, and capital B equal to small b. So now there is a solution of A, there is a epsilon production of A gives epsilon. This particular rule having the value. So that situation, you have containing epsilon production, we need to we substitute A gives epsilon in the given grammar. That case, A gives epsilon means A gives A epsilon will be generated, and finally A gives small a, we get it, and S gives AB, we can substitute S equal to A, S gives AB, so substitute A equal to epsilon means epsilon B, we called as capital B, so now epsilon will be removed. After the simplification of epsilon production rule, the grammar should be in the form of A gives small ab, A gives small a capital A available, and capital B is small b. So A gives small epsilon will be presented in the given grammar. So we need to be eliminate that situation we called for. After applying A gives epsilon, we will get the new rule for S gives B and A gives small a. So that the simplified grammar after the epsilon production is S gives AB or capital B, A gives small a or small a, capital A, another alternative small a, and B gives small b. Second rule, second concept is elimination of null production. Elimination of null production, unit production. Elimination of unit production means one non-terminal exactly gives another one non-terminal. That concept is unit production. So here, given grammar you have to write. After that, to identify any unit productions are available or not. Here, A gives small capital B is producing the unit production. So unit production means one non-terminal exactly gives another one non-terminal. That is case for unit production is present. So here A gives B is unit production. So we need to be eliminate just nothing but in the arrow mark right against what is the non-terminal capital B. The corresponding production rule will be replaced here means the unit production will be removed. So that finally the given context-free grammar simplified is S gives AB keep as it is. A gives B instead of capital B we can replace the corresponding equivalent rule AB here so that A gives small a or small b and keep as it is for B gives small a or small b. Consider this particular rule. Second example, S gives AB, A gives small a, B gives capital C, C gives capital D, D gives capital E. Here, three unit productions are there. A, B gives C gives D, and D gives E. There are three unit productions are there. Out of three, we need to be, how it will be involved, how it will be solved means, just what is the answer? Just D gives E, corresponding equivalent value will be replaced means E gives A. So instead of D gives E, we replace D gives A. Now consider the next rule, C gives D, D having A value, that particular A value replaced in the D position. So C gives A. And B gives C, C in the position will be, the equivalent value will be here A, so B gives A or B. So that is value final result. S gives A, B keep as it is. A gives small letter A is keep as it is. E having small a and D having gives E. Instead of E location, A value will be replaced here. Next C gives D. Instead of D position, D equivalent value A is replaced here. And B gives capital C or small b. That particular location, capital C production rule alternative will be replaced here. So P gives small a or small b. So this is the simplified form after the unit production removal. Third case, eliminating of useless symbols. So useless symbols will be eliminated in two point of view, identifying the non-generating symbol and identifying the non-reachable symbol. So there is a two cases will be considered for useless symbol removal, non-generating symbol and non-reachable symbol. For example, E gives small e capital B or small letter E, and A gives small a. Here generating symbols are E gives small a gives small a. So E gives small e, A gives small a. Generating means what we define here now. Whatever the given production rule is given, once the capital symbols is possible to reduce, is possible to generate, or possible to give a small letter character means, in terms of terminal means, the non-terminal we called as generating symbol. So one non-terminal is possible to generate there, or possible to replace it by a small letter character means the rules are non-terminal is generating symbol. Suppose reachable symbol, here A is not reachable. Here capital letter E is a starting symbol. From the starting symbol, there is not possible for capital letter A relationship. So capital A is separately present. So this is an unreachable symbol, we need to be eliminated. And the capital letter B available, there is no production rule for capital letter B definition. So B is also a non-generating symbol, so that out of this particular rule, the simplified grammar will be E gives E alone. Consider the next example. S gives A capital A small a. Another alternative, A capital B small c. A gives A capital S small b capital D. B gives A capital B small a or small b. C gives A double B or 2 capital D. D gives A capital D small a. E gives F small b. E gives F B. F gives C. So this is your given rules. Out of this, we need to be eliminate unreachable code, useless symbols. Just we discuss about capital A is possible to replace either capital B or small b concepts. So capital A there is a possibility for A capital S or B capital D. So capital D, we have to check A, D, small a. So D, there's no possible for produce a small letter characters because D gives A, capital D A. Again we replace A, D, A. Again we replace A, D, A. So there is no solution for capital D will not be changed to small letter characters here. So that here D is unreachable code, a useless symbols. So that particular case, B into D also to be removed. AS, A or capital B, AS, S is in the position. So now we have to check B value, B, A, capital B, small a or small b. So whatever the derivations, there is a possibility for convert this capital letter into a small b. So B is useful. So B useful means S is useful. Automatically A is also useful. So S, A, B are useful symbols. C, A, B, B possibility for that is also useful symbols. Here D is useless. So this particular D value also to be eliminated. BD value is also to be eliminated. F gives FB. Again E equal to FB. FB. There is no relation from SAB to E value. So E and F is also a useless symbols. So final result will be S gives A capital A small a or A capital B capital C or small c. Next A gives small a S and B having another value for BD. Here D is useless symbol so that it will be removed. B gives A B A or small b, that is also useful. C having alternative A double B or DD presented. Now D is not in position, so D is unreachable. So next E equal to FB, F is equal to C, that is also to be unreachable code. Finally, we will get a result for S is equal to A capital A small a or 1 A capital B small c. A gives AS, B gives ABA or small b, C gives ABB. So in this way, the grammar will be simplified. So totally, we have the three combinations of simplification process: elimination of unit production, elimination of unit production, elimination of useless symbols. So that's all about our simplification techniques. Next, we discuss about Chomsky normal form. Chomsky normal form means we have to define normal form. So the production rule having on specific structure representations. Why we go for normal form? So in generally, the context-free grammar production rules are in the form of arrow mark. That means production rule left hand side is one non-terminal, right hand side there is a combinations of terminal and non-terminals. There is no specific restriction how many characters will be present, whether the string only is terminal only present, non-terminal only present. Just it will be represented in the arrow mark right hand side of the production rule. The production rule right hand side is always combinations of terminal and non-terminal. So that situation, so in terms of we are implementing in a machine, there is a possibility for confusion about how much of time it will be taken, and as well as the allocating of memory is also having wasted. So for reducing that particular practical difficulties and efficiency improvements, we convert the context-free grammar production rules into a specific structure. Each and every rule or every production rules must be satisfied a particular structure format to be remodified. That we called as normal form. So generally, normal form two types: CNF concept and GNF concept. Now we discuss about Chomsky normal form. Chomsky normal form in short form we tell as CNF. So before going to apply the normal form in the given grammar, it should follow all the simplification of CFG techniques. So the given grammar should be in simplified form. Otherwise, we need to be eliminated. How it will be eliminated? There is a possibilities of three production rules are available, either epsilon or unit production or useless symbols. If any one of the rules, any one of the technique will be implement appropriate in the corresponding production rule, we eliminate those epsilon, unit production and useless symbols and convert the grammar into simplified form. That particular simplified grammar is input to the Chomsky normal form. This Chomsky normal form syntax is only two specific syntax. In each and every production rule must be satisfied two rules. First one non-terminal exactly gives two non-terminal alone. And another next rule, one non-terminal exactly gives only one terminal character. That means capital letter non-terminal symbols. Non-terminal gives non-terminal, non-terminal. Next syntax rule, non-terminal gives terminal. So maximum of arrow on right hand side, two capital letters or one small letter. Example, S gives ABC, S gives C1C, C1 equal to AB. So first rule is not in CNF, second rule is in CNF, third rule is in CNF, but first rule is not in CNF format. Next, convert the grammar into CNF. First, eliminate. S gives A, capital B, small b. And A gives small a. B gives small b. Now, compare those three rules. A and B rule will be in the CNF format. Because arrow mark left hand side, one non-terminal, arrow mark right hand side, only one terminal for both A production rule and B production rule. So we no need to convert these two rules. Next, we have to concentrate this rule alone. S gives A, capital B, small b. So check these rules only to be checking. So before going to apply any other null production, unit production, useless symbols are available or not, we need to be verified. In this given grammar, there is no epsilon rules. There is no unit production. Useless symbols means SAB. S is converted into AB format. A or B will be converted into small letter characters. So all the rules are in CNF simplified format only. So now you have to check. We need for this rule only, we need to be simplified. So that case, the requirement will be arrow on right hand side, maximum two capital letters. Here 4 letters are there and along with terminal and non-terminal combination. So first small letter A is also we need to convert and last small letter B is also need to be converted. So that particular purpose, we add a new rule, X gives A and Y gives B. That particular case, we add a new rule, X gives A, Y gives B. So that immediately S will be updated as S gives X, capital A, capital B, capital Y. Now you combine together, first XA will rewrite as C1, BY rewrite as C2. Now the simplified grammar is, S gives C1, C2. C1 gives XA, C2 equal to BY. Next, X gives A, Y gives B. And a given problem, given statements, A gives small a, B gives small b. Here, so this is next concept. E gives E plus T or T. T gives T star F or F. F gives open bracket E close bracket or ID. So in this rule, we need convert CNF format. Here there is no null productions, but unit productions are there. What are the unit production? E gives T, T gives F, F gives ID. So there are rules will be available. So we need to be eliminate. After the elimination of the given rule, what is our answer? T gives T star F or F. F having the production rule, open bracket E close bracket or ID. This value will be replaced in the position of T. Now E gives T rule, T having the production rule for T star F or open bracket E close bracket or ID. That value will be implemented in E equal to E plus T or T star F or open bracket E close bracket or ID. So this is our simplified grammar. Now each and every symbol will be used to converted into small letter characters as a possibility. All the non-terminals, everything will be useful symbols. There is no useless symbols. So automatically everything will be useful one. So we have to convert some new values. So this is our simplified grammar. That value will be implemented into, this value is implemented into CNF structure. So CNF characters, here what are the operators are available? E plus T. So we can add a new rule. X gives plus, Y gives star, and open bracket close bracket having Z and A. So we can add it. So automatically the rules will be in the form of E gives E plus T replaced by E X T. T star F replaced by T star Y. Open bracket E close bracket replaced by Z E A or ID. Similarly T and F rules. Now you have calculate EXT, we replaced by C1T. What is the C1? C1 is nothing but EX. Now this particular rule TYF we can rewrite as C2F. What is the value of C2? TY. Next ZEA we replaced by C3A. C3 value will be ZE. Next ID is 1 characters. Similarly for C2F, C3A ID. Here C3A ID. That is our simplified format of the CNF rule of the given grammar. So this is the way we convert the given grammar into CNF. One main key point is in CNF, whenever you can add a rule means the newly added non-terminal which is not already existing in the given grammar. Suppose here we are using a new non-terminal X, Y, Z, A. So 4 new non-terminals are adding. Add of X gives plus, Y gives star, Z gives open bracket, A gives closed bracket. So these 4 non-terminals X, Y, Z, A, which is not in the given, already in the given rule. So we can add a new production rule means the new production rule non-terminal is purely new non-terminal for the particular grammar alone, not for existing in the given grammar. So except E, T, F non-terminal, you can utilize any capital letters. Except ET plus we can implement. So that is in this these are the ways to convert the given grammar into CNF formats. That's all about the concept of convert of the given CFG grammar into CNF. For the next video, we will discuss about the conversion of context grammar into GNF rule. Thank you. Thank you, students.